Henderson-HasselBalch equation of buffer solution. A buffer solution is usually consists of two solutes. Solutes are what you call solids, which dissolved in water. One of the solute is a weak acid and the other is its conjugate base. A weak acid and one of its salt. A weak acid plus a strong base. So the salt is a strong base. Let HA be the weak acid. It will partially dissociate. That means a small portion will be H plus and A minus. And we're going to have a large reservoir of HA. We need the conjugate base. This is the acid that's conjugate base. We need a large quantity of conjugate base. So therefore, we get the salt metal, which is a strong base. And we dissolve that in the solution where you get the metal plus completely dissociate and large quantity of the conjugate base. So in the solution now, we have large quantity of the acid, the weak acid, and a large quantity of the conjugate base. So this is a buffer solution, which is the large quantity of the weak acid and a large quantity of the conjugate base. And that's what we call a buffer solution. Let's test this buffer solution. If we add a base to the buffer solution, the base will remove the H plus, because a base will remove the H plus. Therefore, more of HA dissociates to replace the H plus that has been removed. So equilibrium will shift to the right, hence replacing the H plus. If we had a small acid to the buffer solution, the acid will remove the A minus. The A minus will react with the acid, forming more HA. So equilibrium will shift to the left. So now we know what the buffer solution is. That's HA with the equilibrium of Ka for the acid plus H plus A minus. So now I can write the Ka expression. So Ka will be equal to concentration of H plus times the concentration of A minus over concentration of the acid. I want to make H plus the subject. So if I come here and write the H plus will then will be equal to, I need to multiply, cross multiply. Don't forget that's over 1. So cross multiply. So I get H plus will be equal to Ka times the concentration of acid over the concentration of the base. And if I can write this properly, it will be Ka times the ratio of the acid concentration over the concentration of the base. Henderson-HasselBalch equation is when we multiply both sides of the equation by log. We know that H plus is equal to Ka times concentration of acid over concentration of base. And if I take log on both sides, log of base 10, so I go log base 10 concentration of H plus will be equal to log of base 10 concentration of what times Ka times Ka. Well, if you're taking log of a product, it's a plus, so that'll become plus because this is a product, plus log base 10 of concentration of acid over concentration of base. Now, what I need to do now is if I multiply both sides by -1, times it by minus, times it by minus, and if I times that by minus, that will become minus. And we know what minus log base 10 H plus is. That will be basically P H will be equal to minus log base 10 of Ka is P Ka, but that's minus because I multiply that by minus, minus, minus. So that will be minus log base 10 of concentration of acid over concentration of base. So that is the equation of Henderson-HasselBalch equation for buffer solution. You can also rewrite that equation by saying pH is equal to pKa plus, if you invert the ratio of the acid to the base, it will be log of base 10 concentration of base over concentration of acid. So whichever one you like to remember, you can use for the Henderson-HasselBalch equation. So let me just put a line through there. So that's two ways you can write the equation. And two ways you can use any way to find the pH. All you need to do is know the concentration is the ratio of the concentration of acid to the base. As you can see, if you change the acid slightly and the base, it's only affecting both the concentration of acid and both the concentration of base. So therefore, that's why it's keeping the pH constant, because it's only affected by the concentration of acid and base. So you can use either the first one here, you can use that one, or you could use this one, whichever one you can use, but you need to remember how to write the equation, and that's the derivation for it.